Good morning. My name is Sudhakar. I'm going to teaching about the basic manufacturing technology. In that, we are discussing lathe and lathe machine, working principles, holding devices, right? So before going to start today's class, what we have learned so far. In the previous class, we have discussed about the various work holding devices, different types of work holding devices, right? Right from the first, we have different types of work holding devices. In that, the main role is for checks, right? In checks also, we are having five types of checks. One is the three-jar check, universal check, and second one is four-jar independent check, magnetic check, mandrel check, and a drill check. So these are the different types of checks we have discussed. After that, another work holding devices are lathe centers, right? Carriers, drive plate, face plate, angle plate, mandrels, rests. So these are the different types of work holding devices we are discussing so far, right? So these are playing many key role while holding the workpieces. Every work holding device it's having its special feature. So in three-jar check we are holding cylindrical objects and hexagonal shapes. In four-jar check we are holding octagonal shapes and rectangular shape workpieces. And magnetic check ferromagnetic material can hold, and the materials which are very thin they can hold in the magnetic material. And lathe centers, so we are having a live center and dead center, so those are called lathe centers. If we want to hold the lengthy job or long job, we are using this lathe centers, right? And after that, carriers. In this, lathe dog is there. So in that lathe dog, we are fixed our workpieces. We have fixed our workpieces, and that lathe dog is fixed on drive plate or face plate. Now, moving to the drive plate. Drive plate. It is also looks like a chuck, but it is having a number of slots on its plate, on its face. So in that slot, we are fixing our lathe dog. Face plate also looks like a drive plate. So also by the combination of these three carriers, drive plate, face plate, by combination of these three work holding devices we are using, right? First of all, we are fixed our workpiece in the lathe dog, and after fixing the workpiece in lathe dog, that lathe dog is having bent tail shape. That tail shape is fixed into the drive plate or face plate. So if the that drive plate is attached to the spindle. If the spindle rotated, the drive plate is rotated. With that drive plate, the carriers getting the motion. The carriers getting the motion. With that motion, the workpiece is rotated. By this combination of these three work holding devices, we are using as a work holding device, right? Now coming to the angle plate. In angle plate, angle plates are used for holding difficult and irregular shaped workpieces, right? So in angular plate, it is like it is like perpendicular plates. Angle plate looks like perpendicular plates. Sorry for the inconvenience. So we are discussing about the angle plate. In angle plate is like perpendicular plates attached with each other. So with the angle plate, we have fixed our workpiece on the angle plate, right? On its slots, it is having slots, and this angle plate is fixed to the drive plate or face plate at one end. So for this reason, we have the weight of the face plate is increased and it is unbalanced. So to balance this force weight, we have put some counterweight on one of its plate on another side, right? So that's why it is balanced. So if the drive plate is rotated, and it also rotates. The types of mandrels. So for hollow workpieces, for hollow shaped workpieces, mandrels are used for holding that workpiece. Types of rests. So this is also rests also used for holding the long workpieces. For long workpieces, rests are used. Right? In these two types of rests are there: steady rest and movable rest. In steady rest, we have fixed this rest at any position of the workpiece. If you are doing some operation on the workpiece, right? Uh, if it is fixed between the two centers, or if it fixed between the two centers, but it produces some vibrational effect. To reduce this, we are using this rest. So the steady rest is fixed at somewhere on the workpiece, right? Where we are going to do our operation, near to that place, we are fixing this steady rest. So it holds the object at that place. So we are reducing the vibrational effect. Okay. So these are all the work holding devices we have discussed so far. Now we are moving to another subject, another topic, that is tool holding devices. In this lecture, we are going to discussing about the tool holding devices. So there are number of tool holding devices for holding devices. Based on the tool, we are having different types of holding devices, right? The cutting tools used in the hexagonal turret requires special holding devices. Okay, so we have discussed about, we have already well known about different types of lathe machines. In that we learned that about the turret lathe, right? Can we recall that in turret lathe we are fixed number of tools on the turret, right? By fixing this number of tools, we are reducing the time to do the some operations on the lathe machine, right? Because if turret lathe is fixed with drill bit and reaming bit and boring bit, right? Uh, or otherwise, take another example. If you want to do the drilling operation and turning operation, if we have fixed two tools on that turret, right? We are fixed already in that turret. Now we are doing with now we have to do the turning operation. We are taking that tool and do the operation, right? And next we are going to do the drilling operation. Now we don't want to remove that tool and fix the drill bit, right? Just we have to rotate the turret and engage that drill bit to the workpieces. So we are getting that operation, right? So this is the use of turret in the turret. Okay. So here you can observe this. The cutting tools used in the hexagonal turret requires special holding device. Hexagonal turret. This means hexagonal. So it is shaped like a hexagonal. So we are fixed only 6 tools on this turret. We have fixed in the this tool. So in this turret, 6 tools. Okay, the cutting tools used in the hexagonal turret requires special holding devices. So in the turret, we have to fix our cutting tools. So to fix our cutting tools, we need some special holding devices. Right? Tool fitted in a holder is designated according to the type of holder. Tool fitted in a holder, right? Tool fitted in a holder is designated according to the type of holder. So based on the tool name, the tool holder names also designated, right? For turning, for drilling tool, and for knurling tool, and for turning tool, for turning tool. So this type of names are designated on the turret. So tool fitted in a holder is designated according to the type of holder. The types of tool holders used on capstan and turret tool. I have already told here 6 types of tools we can use at a time. So here types of tool holders. Tool holders names these are. So these are the straight cutter holder. First one is the straight cutter holder. So in that straight cutter holder, we are using straight cut operation and straight cut tool. Multiple cutter holder. So multiple cutter. So we can call it a little bit as a multiple cutter holder. Right? So in this holder, we can fix the drill bit or framing, but we are not fixing the boring bit in multi-cutter holder, because even though it looks like a drilling operation or uh, finishing operation, but it is a single point cutting tool. Drill bit is having a single point cutting edge. That's why we are not fixed our drill boring bit in sorry boring bit in multiple cutter holder. We can fix a drill bit in multiple cutter, because drilling is having a multiple point cutting edges. That's why we are fixed in a multiple cutter holder. That's why drill bit is fixed in a multiple cutter holder. But boring bit is having a only single point cutting edge. That's why it is not fixed in the multiple cutter holder. Now knee tool holder. So it is a special type of tool holder. In flange tool holder, there are tools which are having flange type of edges. We are fixing that type of flange tool holder, knurling tool holder. So in our operation, we are using knurling also. So in that tool holder, we are fixing the knurling tool holder. Next, farm tool holder, roller study tool holder, die holder, right? So total 1, 2, 3, 4, 5, 6, 7, 8, 8 types of tool holders we have in type of capsule and turret. So by one we have to discuss about the every cutter holder. In straight cutter holder, each of the tool is hold. In multiple cutter holder, each tool is hold. So based on the tool holder, which type of cutting tools we are going to fix in that holders, right? So that is the main thing we have to know about every tool holder, right? So we have fixed the we learned so far up to work holding devices. Now we are discussing about the tool holders. In that, we are having different types of tool holders here. In that, which of the tool is going to use in that holder? Right? Straight cutter holder. Tool is held perpendicular to the holder sheet, right? Straight cutter holder. Which of the tools are fixed in this holder? The tool is held perpendicular to the holder shaft. So observe figure first. So here, this is our cutting tool, right? This is our cutting tool. This cutting tool is fixed to the holder shaft, perpendicular to this holder shaft. This is the holder shaft, right? This is the holder shaft, and to this, the tool is perpendicularly fixed with the nuts. This is tools are nuts. Okay. So operation is going like this. So our workpiece, our cutting tool is moving in this direction. Here we have to observe this tool holder, right? In this tool holder, we are fixed our cutter perpendicular to the shaft, right? So we have already observed that tool is held perpendicular to the holder shaft, axis by 3 set screws. I have already seen you that set screws that are fixed to the tool holder, right? The shaft can be mounted directly into the hole of the turret cage. So, which of the shaft? Shaft, this shaft is directly fixed to the turret hole. Right? This shaft is directly fixed to the turret hole. With that shaft, we have fixed our shaft. It is used for turning, facing, and chamfering right? So the tool which is fixed in straight cutter holder, it is used for turning, facing, and chamfering operation. Once again, telling you that the straight cut holder, in this holder, tool is held perpendicular to the holder shaft, axis by 3 screws, and the shaft can be mounted directly into the hole of the turret face. The shaft can be mounted directly into the hole of the turret face. The spool, which is fixed in straight cutter holder, that is used for turning, facing, and chamfering operations. Right? So we can simply tell that these are the single point cutting tools because it is having only single point cutting edge. So for that reason, we are using turning operation, facing operation, and chamfering operation. Right? So this is the diagram we have here. This is our workpiece, the hollow workpiece. Here we are removing the material. Right? This shaft is directly fixed to the target hole. So this is the straight cutter holder. Right? This is our cutting tool. Next, multiple cutter holder. You can observe this multiple cutter holder. So multiple cutter holder. So this is we are fixed two different tools. Okay, two tools, not different tools. Two tools on the same shaft. Same shaft. We are fixed with two tools. So these tools are you doing the simultaneous operation. These multiple cutters are doing simultaneous operation one by one. So this is the multiple cutter holder. Multiple cutter holder. So it can accommodate double tool in its body. Multiple cutter holder can accommodate a double tool in its body. It facilitates the cut simultaneously with more than one tool from the same tool station. Its shaft is mounted directly in a hole of turret face. Right? So multiple cutter holder accommodate a double tool in its body. Already we are observing the figure. It facilitates the cut simultaneously with more than one tool from the same tool station. Its shaft is mounted directly in a hole of turret face. Its shaft is mounted directly in a hole of turret face. Same like a single cutter holder. Same like single cutter holder. Multiple cutter holder shaft is also fixed in the turret face. Observe this figure now. So these are the two cutters fixed to the shaft with the 6 screws. So this shaft is directly going into the multiple turret hole, directly fixed into the turret hole. So these multiple cutters doing simultaneous operation. Multiple cutters doing simultaneous operation. So the multiple cutter holder. multiple cutter holders. Both are multiple cutter holders, and this is the shank which is directly fixed to the red hole, right? Next, knee tool holder. Sorry here. So this is the like shape like knee type. That's why it is called as a knee tool holder. Okay, knee tool holder. It is directly bolted to the target. So not like single point and multiple point, but single point of tool holder and multiple cut of tool holders are their shanks are directly going to the holes of the turret. But in knee tool holders, it is directly bolted to the turret face. It is fixed to the turret face. Additional support is given by the overhead pilot, which is located in the bush. Additional support is given by the overhead pilot, which is located in the bush. Right? It is useful for simultaneous turning and boring and or drilling operations. Here you can observe this. It is used for turning and boring. These are the two different operations: turning operations, boring or drilling. Right? So additional support is given by the overhead pilot, which is located in the bush. So here the additional support, we are having additional support, which is fixed on the overhead of the bush. So this is the knee type holder. Knee type holder. It is directly folded to the turret. It is directly folded to the turret. Now we are moving to flange tool holder. In this, the tool holder, the flange tool holder is bolted to the hexagonal turret. It is bolted to the hexagonal turret. It is widely used for holding boring bars, centers, shank type tools, right? Flange type holder, tool holder is bolted to the hexagonal turret. It is widely used for holding boring bars, centers, shank type tools. Like knee tool holder, it is also bolted to the hexagonal turret. But before two holders, straight cut holder, multiple cutter holders, both are having shanks. The shanks are directly into the holes of the hexagonal turret. The flange tool holders and knee type tool holders, they are directly bolted to the hexagonal turret, and this flange type tool holders is widely used for holding boring bars, centers, shank type tools. So this is our flange type tool holder where we are having the flange. Flange is here, and these are the two holes are fitted to the workpiece. Cutting tool, this is all sorry. This is fitted to the turret. This is fitted to the turret, not to the workpiece. This flange is fitted to the turret. Flange tool holder. Here our flange. Right? This is our flange. And next one is knurling tool holder. Knurling tool holder means the knurl tool we know already. The knurling is used for gripping purpose. Knurling means we are giving some indentation on the cylindrical part, right? Why that we are called? Why that we need that process? Why do we need that process? Because knurling produces the indentation. That indentation is used for our gripping purpose, gripping of the tools or workpieces. For that reason, we are using knurling operation. To do that operation, we need a knurling tool. To do the knurling tool operation, from that knurling tool holder is firmly fixed in the knurling tool holder, right? So it is fitted to the turret face. Knurling tool holder is fitted to the turret face, and the diameter of the workpiece adjusted by the our knurls, right? So the diameter of the workpiece is fixed in between the two knurls that can be adjusted by the knurls, right? So the knurls can be adjusted to knurl on different diameter work. So we can adjust these diameters. We can adjust this. Okay. The knurls can be adjusted to knurl on different diameter work. Okay. So here the gap is to insert here workpiece, right? So if the longer work, if the diameter is increased, these both are adjusted. These knurls both are adjusted to fit that workpiece in this gap. In this gap. So you can tell that the knurls can be adjusted based on the work, based on the diameter of the work, right? So this is the knurling tool. So in this gap we have fixed our workpiece, right? This nulls are adjusted based on the diameter of the workpiece. For different diameters, they can be moved up and down, right? In and out. So if the diameter is more, they can be elongated. If the diameter is less, they can be come to the near direction, right? To fit to the part. Okay. So for that we are called it as a null, and this is adjusted. In this nulls are adjusted for different diameter of form tool. So form tool, this type form tool we learned at taper turning operation, right? Have you remember taper turning methods? In that taper turning methods, one of the method is farm tool method. The sentence means farm tool means whatever the shape we are going to produce on the workplace, that the shape is that the shape should be on the cutting tool itself. That opposite shape should be on the cutting tool itself. So that type of tools we are called as farm tool, right? Suppose, let us take some example, the taper turning. If we want to produce taper turning operation on the cylindrical part, so that tool also similar to the taper shape which are going to produce on the workpiece, right? So now directly we are fed our workpiece onto the fed our cutting tool onto the workpiece. So whatever the shape is having on the cutting tool, that shape is reproduced on the workpiece. That shape is reproduced on the worksheet. So those are called farm tools, right? So it is we learned that the paper turning method. This is the one of the method. Paper turning farm tool method is the one of the method. So to hold, so this type of tools, where this type of tools are fixed, tool holder is mounted on a dovetail slide and its height is adjusted by moving within the slide. Tool holder is mounted on dovetail slide on and its height is adjusted by moving within the slide. Circular form tool is held in similar way and its height is adjusted by rotation. Okay. Circular form tool is held in similar way and its height is adjusted by rotation. Both type of tools, right, are held in a dovetail slide and its height is adjusted within the slide and adjusted by rotation. Circular form tools also. Palm tool holder is usually held on cross slide. Palm tool holder is usually held on cross slide. Okay. So this is the straight form tool hole. Straight form tool hole. So this entire thing is the tool holder. So it is directly onto the cross line. Here the tool holder is having a tool, right? Is straight form cutter. Is straight form cutter, and it is doing operation here. So observe here which operation is happened here. So maybe a facing operation. It may be a facing operation, right? So this is the tool holder, form straight form tool holder. In this, the straight form cutter is fixed. Okay, so this form tool holder is usually held on cross slide. Okay, tool holder is mounted on a broken slide, and its height is adjusted by moving within the slide. Circular farm tool held is similar way, and its height is adjusted by rotation. Okay. Farm tool holder is generally these are used in usually held on cross line. So this is the straight farm tool holder. The straight farm tool holder. In this straight farm tool holder, we have fixed the straight farm cutter. Okay. So here the piece is rotating. Now we are directly attaching our directly fit our cutter to this workpiece. Directly fit our cutter onto this workpiece. Right? So the operation is happening here. Right? So these are the tool holders, plain type tool holders, normally tool holders, straight form tool holder. The next one is roller study tool holder. Roller study tool holder. Observe this figure, roller study tool holder. These two are rollers. In this, we have fixed our workpiece, and this is the cutting tool doing this operation. Okay. So whenever these rollers, study tool holders are used for us, now we have to observe here, rollers and tools are contained within a box-like structure. So the entire thing is looks like in a box-like structure, right? Is it correct? Right. Both rollers independently mounted on slides can be adjusted for wide range of diameters. Both rollers independently mounted on slides can be adjusted for wide range of diameters, as we observed in the diagram or figure itself. They are improved surface finish. No deflection of the workpiece leading to inaccurate work. Here you observe this is the workpiece. These are the two rollers. They are adjusted on the different slides. Okay, these are the different slides, and these rollers are adjusted for different types of diameter workpieces. Here the cutting tool is fixed. Is going to run the operation. By doing this roller study tool holder, the workpiece may get a good surface finish, and because of two rollers are supporting the workpiece. So while doing the operation, no deflection of the workpiece leading to inaccurate work, right? So there is no deflection happened while doing the operation, right? So by this we are using this roller study tool holder. In this, two rollers are there. They are independently mounted on slides and can be adjusted for different type diameters. Different type diameters are now fixed on the these roller study tool holders, and by doing this, no deflection is happened, and it should produce improved surface finish, right? It looks like box box looks like box type structure, right? Here observe, so the cutting tool and rollers, right? So we are getting good surface finish. And the next one is die holder. Here, so this is the die holder we are having. Okay. The die, self-opening die head is used for cutting external threads using a capstan lathe. Self-opening die head is used for, this die head is used for producing external threads, and it is used in a capstan lathe, as we have learned in the capstan types of lathe machines. That name is capstan lathe. By this tool holder, accurate threads are produced by adjusting the dies, adjusting the cutting dies. By this tool holder, accurate threads are produced by adjusting the cutting dies. The machining time is reduced by doing this operation. The machining time is reduced. So this is the die holder. Yeah, using die holder. This is used for external threads operation. External threads operation. And accurate threads are produced by adjusting the screw threads, and the machining time is reduced. Right. So far we have learned about the types of tool holding devices, right? Tool holding devices, we have different types. We have learned that different types of tool holding devices. Once again, we can recall: straight cut tool holder, multiple cutter tool holder, knee type tool holder, flange tool holder, nub tool holder, right? And die type, die holder, roller study tool holder, straight form tool holder. Okay, these are the types of tools we have learned so far. These are all tool holding devices. Can we answer some of these questions? Which type of tool holder is used for turning as well as boring? Straight tool holder, knee tool holder, palm tool holder. As we learned, the type tool holder. In knee tool holder, we have fixed at the same time turning and boring or drilling tool holder. So the answer is knee tool holder. Palm tool holder is held on cross-slide, tailstock, square tool post, headways. So palm tool holder is held on cross-slide. Right? So from this, the frequently asked questions: write short notes on palm tool holder, draw a neat sketch of the knee turning tool holder, and write the applications. Right? Now we are moving to the tool geometry. What are the types of? Now we are moving to the types of lathe tools and the term related to the lathe tool geometry. This is a very important point. Lathe tool geometry, we have to learn it, right? In the future classes also. The lathe tool geometry is very important, right? So before going to discuss about the tool geometry, right? Just we have to observe number of types of lathe tools. This lathe tool geometry will be discussed in the next class. Today we stop here on the types of lathe tools. Right? So observe these operations. Right? So these operations are already we learned so far. Already we learned so far all these operations we learned so far. So here straight cutting operation. So this gap is called depth of cut. Here we are reducing the diameter of the cylindrical workpiece. So this is the tool. So to do this operation, we are doing some depth of cut. Okay, come to here and observe these tools also. The turning operation. Observe this tool cutting edges. Now move to taper turning operation. Right here we are producing taper shape. Right? Taper is nothing but again I am repeating taper Turning means it reduces the diameter. I mean, here the diameter is gradually decreases or increases in taper turning operations. Here you have to observe this cutting edge of the cutting tool. Now come to here. Here some special type of profile operation here it is. So for this we have used this tool. Okay. Here the color is here two colors. The entire two color is same. Right? Here the entire two color is same because it is a same tool. Entire part is same material. Here also entire the part of the tool is same material. But observe here. Here it is having one color and it is having another color. So what indicates is here this material is different and this material is different. We are attaching this cutting edge to this uh, tool, right? So it is its cutting edge is made with another material, right? It is attached to this material tool, right? We come to here turning and external grooving. For this also we are having different materials. It is also one material and this screw material also another material. Okay. So by doing with this, we are using turning and external grooving operation. Turning and external grooving, both are combination part. Here, turning operation is happened, that is reducing the diameter, and grooving. Grooving means some slot. Some slots are here. Slot. This entire part is called slot. So slots are produced by grooving operation. Then come to here, it is a facing operation. And facing operation is also made with the same material, single material only, single point cutting material only. It is done. Right? And face grooving operation here different materials. Here is also one material, and this cutting edge is made with another material. Cutting edge is made with another material. And cutting with a form tool. I have told that the form tool means the which shape we need which shape on the workpiece. That shape is also on the cutting tool, right? Here by this form tool we produce this part. We produce this part. To do this operation, similar shapes on the cutting tool. We need similar shape on the cutting tool. So it is reproduced on the workpiece. Its shape is reproduced on the workpiece, right? Here, this is called a farm tool method, and this farm tool method, this material is also made with the same material, right? And boring and internal grooving, right? Boring also, it is a single point cutting tool. This boring tool having a cutting edge with another material, right? And here what happens, boring means enlarging the hole and also some grooving operation. That means different type of diameter holes. Different type of diameter holes are produced in this operation. That's why it is called as a boring and internal grooving, right? And the drilling. So here we observed that a drilling operation. Here the drill bit is there. The drill bit is doing drilling operation and it is made up of only single material. Right? Here also, here it is another material and it is another material. The cutting edge is made with another material. Right? Cutting off. We know this cutting off operation. After completion of the work, we are removing the completed part from the base part, right? So for doing this operation also, we need some tool. The tool is having two materials. One is made up of this material and another one is cutting edge material, right? So this cutting edge material is made with another material. So the cutting operation also, the tool is having different types of material. Threading operation. Come to here. Threading operation means external threads, external grooves or helical grooves produced on the part. So to do this operation, we are engaging off-nut mechanism. By engaging that mechanism, threads are produced, right? So the pitch which is moving on the lead screw, the pitch is produced. So by that distance, the tool is travels. And with the traveling, we are producing threads on the nut part, right? When we come to knurling operation, in knurling operation, we clearly observe that the knurl tool which are having different materials, the knurls which are hold on the holder is made with another material, right? So the knurls is made with another materials, and the tool holder is made with somewhere another material, right? Here we are observing the knurling operation. The knurling operation, we know that different nulls, I mean indents are produced on the null, right? So all these figures show that some of the tools which are using for some particular operation, some tools are made with similar material on the entire thing, and some tools made with two materials, that the base part is made with some material and its cutting edge made with some material, right? So these are the tools by doing some operations. In earlier classes we learned that lathe tool operations. Here the tools which are used for particular operations we have learned, right? So once again recall these operations. Turning produces straight, conical, curved, or grooved workpieces. Facing produces a flat surface at the end of the part. Drilling to produce a hole. Cutting off to cut off a workpiece. Threading to produce threads. Produces knurling means a regular shaped roughness. So these are all data operations we have done. And for doing these operations, we need special types of tools, right? Some of them are made with a single material only, same material at the entire part, and some of the materials are made with different materials, cutting edge made with different materials, right? So with this, I concluded today's session. Today we learned so far tool holders, different types of tool holders, and different types of tools. The tomorrow's class and the next class, we learned about the tool geometry, right? What are the shapes and what are the parts are on the tool that will be learned in the next session, right? Today I am closing.